Hello and welcome again to this YouTube channel. So now we proceed to a more challenging ways to solve y prime. Okay, so I have two different examples here. The first one involved with a quotient. Okay, the numerator and also denominator type problems. And the second one is when you have the power of your function. All right, so now your function is one. Your function is a composition of a addition function, and then at the same time you multiply them a lot of time. Okay, so how to solve this? Okay, the first one, we solve the first one first. Okay, if you notice on the previous example, we have a product function, all right, and then you have the product rules, okay, whereby once you have y equals to uv, and then you're going to solve the y prime now becomes uv prime or u dv dx plus v du dx, and then you solve it all together. But now once we have this quotient rule, okay, you do the same thing. Okay, you transform this into your u, and then you transform this into your v. In this case you have u equal to 4x minus 1, and then you do the same thing for your u, find your du dx. In this case you have only 4, and then your v is x square plus 3, and then you find the first derivation for your v. Now it becomes dv dx equals to 2x. All right, so this is the most elementary things that you need to do, and then now we can start finding our dy dx. Okay, if you notice, I never do y for my u, and I never do v for my y for my v. Okay, why? Because you always have to remember this is very tricky. All right, this one is u, this one is v, and this one is y. The final things that we need to do is we need to find the derivative for my y, meaning that my final answer should be in the form of dy dx. All right, so once we clear that one out, okay, now in this case, how to do just that? We start with the denominator first, and then we put the du dx, and then we do the counterpart of it. Okay, so now in this case we have dvdx, and then we divide them with v square. All right, so once you identify that, okay, the rest is just plug in your formulation. Okay, we start with this, and then we start with we proceed with du dx, and then similarly you have 4x minus 1, and then you have 2x, and then we divide them all together with my x square plus 3. Do not forget your square for the rest of your v. All right, once you have this, you can just simply solve this. Okay, okay, it's like, okay, the space is a little bit tricky to do it. Okay, but that's okay. So to reduce my mistakes, okay, I do it one by one. Okay, and then this one should be plus. Okay. All right, and then oops, okay, over here, and then I just simplify all the value that I have. So actually this is what I have. Okay, I have 4 minus 4x square, and then plus 2x plus 12. Okay, do not forget your denominator. All right, so you can just leave this as it is, okay, because this one is already simplified already. But if you are a little bit very very diligent, you can just find the factor for your 2 on your denominator. Okay, but it does not change any does not change that much. But it's okay if you want to simplify it even more further. Okay, if you want to fix it it is also okay. No problem. If let's say you want to uh, expand your denominator, also okay, but I don't think that will help you that much. All right, so as long as you get the answer. Okay. Okay. By the way, you always have to remember, the idea of finding this is for you to understand why you use the kind of formulation. Okay. But if let's say you are already in a position where you know how to do this, and then at the same time you are dealing with a real world application, okay, you don't have to worry in a sense of finding the difficult part of it, okay, especially if you are dealing with a lot of data, okay, because you always have to remember um, uh, most of the thing that we do, okay, if it is very complicated and very difficult, especially in a real world application, we can always transfer all our intention and all our derivation into computational effort. Okay, that's why we have supercomputer, and in fact our computer is also sufficient enough to solve this kind of problems. Okay, but the most important part is for you to be able to understand why you do the maximum part, why you have to do the f prime, and in fact later on, once we are able to understand about the higher order differentiation, in the sense we have not f prime anymore but f double prime, f triple prime, and so on. Okay, but you need to know the fundamental principle behind that first. Okay, so I hope you get it. Okay, now we move on to the next question. No, so now in this case, this is a little bit like the previous example plus uh, the simple example, but in this case, when they put them together, that's why you get a little bit confused, but the idea is the same. Okay, the idea is like this, okay, I'll show you a little bit. Okay, the idea is like this. If let's say you have y equal to fx to the power of n. Okay, so when you want to find dy dx, actually you use the similar concept as how you get your x to the power of n. In fact, okay, but in this case you are dealing with f. Okay, but now you just put your n exactly as you have x to the power of n. For example, so you put n and then you have f and then you reduce the power n over here. But now the difference between this particular problem and also the last problem is f. Okay, since you are dealing with f, you cannot just simply put f as it is, kan, because it does not give it is not fair, all right, for the f. So once you have until n f to the power of n minus 1, this is the difference. Okay, you need to prime the one inside your bracket. Okay, in this case actually you need to prime your f. Okay, that's the difference. All right, so we put this into our mind. Okay, so now we are ready to solve this. Okay, meaning that my n is just 37. Okay, and then this is my f. So if you notice, see, I didn't change anything inside my bracket because I know this is my f, and then what I change is only the power of my bracket, which is I reduce to 1, and then now I introduce another changing position whereby I prime the one inside my bracket, which is actually my f. Okay, so when I prime the one inside my bracket, I have 3x square plus 2. Okay, all right. Okay, so okay, I try to, it's not a simplification, it's more like a makeup. Okay, I'm doing some makeup over here. Okay, so I put the one with a lower lower power at the earlier area, and then I put the higher power there. Okay, if you want to change it, doesn't matter. I just want to make it a little bit more beautiful. That's it. Okay, so I hope you understand the concept for these particular examples. We will move forward to a little bit more examples later on. So I'll see you guys in the next lesson. All the best.